Pre-Calculus Chapter 2, Lesson 3, we're going to wrap up this lesson by combining all these things we've been learning to now sketch the graphs of these polynomial functions. We've learned that they're smooth and continuous throughout. We've learned how to determine what the ends are going to look like. We now know how they're going to either cross or touch the axis by looking at the zeros. So if we put all those points on there, then we just connect those points, we'll have the graph of the polynomial. Okay, so we're going to put all those things together. So as we talked about, we first wanted to determine the degree, because that's going to tell us how the ends are going to, what the end behavior is going to be. We can then look at the zeros and tell what's going to happen at the x-intercepts. The multiplicity, you remember, will tell us if it's going to cross or touch, and it also gives us what it's going to look like close to that zero. And I'll talk about this when I do the first examples. We didn't talk about this too much or at all in the video previously. We'll talk about how we know how it's going to look right at that zero that's being determined by the multiplicity. And then we're going to connect all those with a smooth curve. So if we follow those 4 steps, we should be able to get these graphs pretty quickly and pretty easily. So for our first example here, let's try and graph this one. So first thing we want to do is we'll put on our scales and we'll label our axes. Okay, so T4, 1, 2, 3, 4. Okay, so the first thing we want to do is determine what's going to happen on the ends. And the end behavior, you remember, is determined by the leading term. The power tells us where the ends are going to be. So this is an even power, so it's going to look like that quadratic. So I know that y values are going to be going up and up out here at the ends. The next thing I want to do is graph the intercept. So I have an intercept at 3 because that's what makes that 0. And I have an intercept at 1 because that's what makes that 0. Now remember, the multiplicity determines whether it's going to cross here or touch here. Okay, now there's one other value that you can figure out, and that is the y-intercept if you want, just to get an idea of where it's going to cross the y-axis. And remember, that's when the x value is 0. So I could substitute in 0 here and figure out the y-intercept. So 0 minus 3 is negative 3 squared is 9. 0 minus 1 and 1 squared is 1. So 9 times 1 is 9. So I know it's going to cross here at 0, 9. So I know what it's going to be doing as I go out this way, and I know all this stuff, and where it's going to cross or touch. All right. Now, just as a reminder, this is a even multiplicity power here, so I know that it's going to touch at 1, and I know it's also going to touch at 3. So I have all my information. I just want to select or draw a smooth curve. Now I know that the end behavior, according to this, is going to be up here, so I know that this is going to come down this way, and it's just going to touch this right here. Okay, now there's one thing we didn't talk about in the last video that I want to cover. The degree of the 0 determines the behavior at the 0. In other words, this is a quadratic 0 squared. So that means right here it's going to look like a quadratic would look right around that 0. Okay, this 0 here is also a quadratic, so it's going to look like a quadratic right here, just around here. Okay, so I know then that because the end behavior is going to be going up, I know that this side of the graph is going to be going up. Okay, and I know that over here the end behavior is going up, so this is going to be going up as well. All right, now notice I didn't try to touch these points. Those are just markers telling me that these go up. I don't have to try to go out that way. These generally go up in a nice sharp curve as we go up. Now what happens between here and here? Somehow, because these are smooth and continuous, it must come back down to here. But how does it do? Does it go straight across? Does it go nice up and coming down? Where does that turnaround take place? Now, there's no way to determine that in this course. That's a concept for calculus. All we need to know is that it's going to turn around and come back down. So you just want to make a nice curve, and somewhere halfway between these two is just make it turn around and come back down, and you can go really high, and generally they're going to be kind of low like this, or they might come across here. We really don't know, but the idea is that it's going to be a nice smooth curve. So if we connect all those, this should be the general shape of this graph. So if I look at that, and you see that's the general shape of the graph that I got just by doing the end behavior in the zeros. And again, the thing here is don't worry about trying to be exactly where does this turn around, because we don't know. It's a calculus thing. We're just trying to get a general sketch of the figure, and as long as I have the end behavior and the zeros and whether it crosses or touches, that's generally the shape that we want to get as we graph these. Okay, I'm going to do a number of examples. You can watch as many as you need as you feel that you will help you. And as soon as you're done watching those or feel like you can do them on your own, go ahead and stop the video and tackle your homework. So here's our next example. So we want to go ahead and label the axes and get our scales ready to go. Now I want to determine the end behavior first. So I look at the degree. This is going to be a first power times a second power. We add those together, so it's going to be a cubic. The leading term is going to be positive, so I know the end behavior is going to be going down as I go out this way and up this way. The next thing I want to look at are my zeros. So here we have a 0 of -2, so it's a -2, 0, and we have a 0 at 0. Okay. Now I want to look at the multiplicities to see if it's going to cross or touch. So the -2, 0 here has a multiplicity of 2, which means it's just going to touch. And because it's a square, it's going to look like a quadratic, so I know it's going to be coming up from here. So right around here, it's going to look like a quadratic does as it turns around and goes that way. That's a little sharp. Let me try that again. So right around here, it's going to be a nice quadratic looking thing. Then at the 0 here, it's a even power, odd multiplicity, so it's going to cross. So this is going to cross, and it's a first degree, so it looks like a line right around the 0. So I have all I need now, so I know that the end behavior is going to go down like this. Now somewhere between here and here, it has to turn around and come back up. So again, about halfway between, you just want to connect that. And then again, these are then going to curve up and look something like this as we go towards positive infinity. Again, I don't try to hit my marks. Those are only marks. These are nice, smooth curves, and they kind of climb nicely out of those intercepts as we go through there. So as we look at this, we'll see what kind of shape we have, and you can see I'm pretty close to what I have. Okay? All right, well, again, if you think you got it, go ahead and tackle your homework. I'm going to do 3 or 4 more examples. If you want to keep watching, go ahead and do that. All right, our next example, we'll go ahead and put our scale on here. So the first thing I want to do is determine the end behavior. So here's a 1, and a 2. So 1, 2, 3, 4. So it's an odd, even power, and the leading term is going to be positive, so I know the end behavior is going to be going up and up. I have a 0 at 0, I have a 0 at -2, and I have a 0 at +3. And we'll work our way across because I know this is going to go up. So the -2 is a odd power, which means it's going to cross. And it's linear, so I know it's going to look something like a line as it crosses right there. The 0 power is a odd power, which means it's going to cross. It also is a linear, so it's going to look like a line. And then the 0 at 3 is an even power, which means it's just going to touch. And I know it's coming from over here, so I know it's going to come down and look like a quadratic and just touch. So I have my end behavior, I have my zeros taken care of, so now I just connect these with a nice curve. Somewhere between here and here, it's going to turn around and come back up, so we'll just do this. Somewhere between here and here, it's got to go up and then come around and back down. Okay, that's a little wobbly there. Let me see if I can do that there. And then it comes down here, goes up, and then it does go up to positive infinity. So like that. Okay, so the graph should look something like that as we put together all the pieces. Okay, and again, I have the general shape, and that's what we're looking for: crossing at the proper places, touching at the proper places, and the end behavior in the right place. All right, another example or two if you want to continue to watch. Okay, this is my last example that I have, so hopefully these have been helpful for you. So let me go ahead and put these on here. Okay, the first thing again is the end behavior. The end behavior is determined by the power, so this is a 3 and a 1. That's a fourth power. That's an odd power. Excuse me, why do I keep saying that? It's an even power. The leading term is going to be positive, so I know it's going to go up on both ends of the graph. I have a 0 at -2, and I have a 0 at +1. The 0 at -2 is an odd power, which means it's going to cross. It's linear, so it's going to look like a line where it crosses. The other zeros at 1, it also is an odd power, it is, which means it's going to cross, and it's a cubic. So right around here, it's going to look like a cubic, and a cubic looks like that right around the 0. So I have everything, so I'm just going to connect these in a smooth curve. Somewhere between here and here, it's going to turn around, so it's going to look something like that, and then right up here, connect that. So it should look something like that. All right, so that's generally the right idea. All right, so as we look at these again, the end behavior, the zeros give us the shape, the parameters, and then we connect them with a smooth curve, and we can quickly sketch the graphs of these polynomial functions.